Hello, 6th grade. This video is going to start our next unit of study, which is over decimals. And so in this first lesson, we're going to review what you already know about decimals and talk about rounding, comparing, and estimating decimals. So we'll start off with the basics. A decimal is a number that is written using a system based on multiples of 10. Okay, all of the decimal places are based on multiples of 10. Each position of a digit in a decimal is 10 times the value of the position to its right. Okay, so it works just like a regular place value to the left of the decimal point, which you learned probably back in first or second grade. So you hopefully by this point know that if I have the number 453.296, by the way, we say this as 453 and 296 thousandths. You hopefully know that the 4 here is in the hundredths place. The hundredth place. The 5 is in the tens place. The 3 is in the units place. And then once you get to the right of the decimal point, that's when we start adding the THs to the decimal places. So this 2 here is in the tenths place, TENTHS. The 9 is in the hundredths place, HUNDREDTHS. The 6 is in the thousandths place. And then we could go on forever to the 10 thousandths, the 100 thousandths, etc. Okay, so as you go to the right, each of those digits represents a smaller and smaller place value. So I want to talk about first rounding decimals, just to be sure you're comfortable with that, because we'll be doing a lot of rounding, not only in 6th grade math, but also beyond. Rounding is important as well in science. So we need to know how to round decimals correctly. So if you're asked to round a decimal to a certain place, the first thing you do is look at the place value you're rounding to, and it's a good idea to just circle that digit so you don't forget where you're rounding to. And then we're going to use this little saying here to help us remember how to round. So after we've circled the place that we're rounding to, then we're going to look right next door. 4 or smaller, just ignore. 5 or larger, add 1 more. So we'll talk about what this means down here as we go through and round each of these numbers. So I have a table here, and we're going to practice rounding to the nearest whole, the nearest tenth, the nearest hundredth, and the nearest thousandth. We'll start with the nearest whole. So I have the number 23.1768. To round this to the nearest whole, I need to look at the units place. Okay, so here that would be the 3 is in the units place. And so what this saying says is look right next door. So we're going to look at the digit to the right of 3, which would be the 1. If this number, the 1, is 4 or smaller, we just ignore, and so we round this to the nearest whole of 23. Looking at 45.3455, we're also going to round this to the nearest whole. I look at my units place, again we'll circle that. We look to the right of the units place, so we look at the 3. 3 is 4 or smaller, so we'll just ignore and we'll round this to 45. 125.3578. Again, rounding to the nearest whole, look at the units place 5. Look to the right of the units place. This is also a 3, so we just ignore, and this is 125. 435.9008. Our units digit is 5. We look to the right of the units digit, and we see that this is a 9. So look at the second part of this saying. 5 or larger, add 1 more. So what this means is if this digit to the right of what we circled is 5 or larger, then we're going to add 1 to the digit we circled. So this 5 is going to round up to a 6, and so this is going to be 436 rounded to the nearest whole. Finally, 236.0895, the units digit is 6, to the right of it is 0. 0 is smaller than 4, so this stays at 236. Okay, we're going to do the same thing now, but now we're going to practice rounding to the nearest tenths place. So this is the second column. So for 23.1768, I'm going to go to the 10th place. which is a 1. I'm going to look to the right of 1, and I notice I have a 7. 7 is 5 or larger, so I'm going to add 1 more to my 1. So this becomes 23.2. 23.2. 45.3455. Again, I circle the tenths digit because I'm rounding to the tenths place. I look to the right. I have a 4. When it's a 4 or smaller, we just ignore. So this is going to be 45.3. 125.3578. I circle the 3. I look to the right. 5 or larger, add 1 more. So we're going to add 1 more to the 3, and this becomes 125.4. What I want you to do now is pause the video and try these last two on your own. Once you have those, click play, please, to check your answers. Okay, so 435.9008 should have rounded to 435.9. 236.0895. 0 is in the tenths place. To the right, we have an 8. So 5 or larger, add 1 more. So this becomes 236.1. Okay, so now we'll practice rounding to the nearest hundredths place. So the hundredths digit on our first number is a 7. To the right of it, we have a 6. So we're going to add 1 more. This becomes 23.18. Next, our hundredths digit on this is a 4. We look to the right, 5 or larger, add 1 more. So we'll add 1 more to that 4. This becomes 45.35. 125.3578. 5. Look to the right, we have a 7. So we're going to add 1 more, and this becomes 125.36. Again, I want you to pause the video, try the next two on your own. Once you have those, click play to check, please. Okay, so our next number, we look at 0 here in the hundredths place. To the right of it is also a 0, so this becomes 435.90. And then lastly, 236.08. To the right of 8 we have a 9, so we add 1 to the 8, and this becomes 236.09. Okay, finally we're going to practice rounding to the nearest thousandths place. So the thousandths digit here is a 6. To the right we have an 8. 5 or larger, add 1 more, so this becomes 23.177. Here, to the right of the 5, we also have a 5, so we'll add 1 more. This becomes 45.346. Here we have a 7. To the right, we have an 8, so we add 1 more. This becomes 125.358. Here we have a 0. To the right we have an 8, so we add 1 more. This becomes 435.901. And then lastly we have a 9 here in the thousandths place. If we look to the right we have a 5, so we add 1 more. When you add 1 more to 9 though, you get 10. And so you have to think about carrying that 1, should I say, that 1 up, just like we do when we do regular 2-column addition, carrying that 1 in the 10 to the 8, and so that actually becomes a 9. So this, rounded to the nearest thousandth, is actually 236.090. Okay, rounding a 9 up will automatically make the digit to its left go up by 1 as well. Okay, so that's a brief review, hopefully, of rounding for you. Now we're going to go to the next slide and talk about how to compare decimals. So when we're comparing two different decimals, we always start with looking at the whole number parts. If the whole number parts are different, then the larger decimal is just the one that has the larger whole number. So for example, 105.36 is larger, this is a greater than sign here, than 103.99 because 105 is greater than 103. If the whole number parts are the same though, then we have to start looking at the decimal places, and so we always start in the tenths place and we compare the tenths digit in our decimals. If the tenths place digits are different, then the larger decimal is just that the one that has the largest digit in the tenths place. So here we have 39.59 and 39.71. Looking at the tenths places, 7 is larger than 5, so that means that 39.59 is less than, this is a less than sign here, 39.71. If the tenths place digits are the same, then we have to go to the hundredths place and compare. If the hundredths digits are the same, we go to the thousandths place, etc., until we get to two different digits in the same place. So we're going to practice this now in examples 2 through 9. We're going to compare each of these decimals using either a less than, greater than, or an equal symbol. So number 2, we have 0.28 or 28 hundredths compared to 0.29 or 29 hundredths. Okay, since they both have a 0 as the whole number parts to the left of the decimal, we'll start in the tenths place. They both have 2's in the tenths place, so then I move on to the hundredths place. Here we have an 8, here we have a 9. 9 is larger than 8, so that means that this number, 0.29, is larger than 0.28, so I need a less than symbol. If the first number is smaller, we use a less than symbol. And remember, the crocodile mouth, which you can think about this symbol looking like, always eats the larger number. Okay, number 3. We have 9.85 comparing it to 9.085. So the whole number parts are the same, 9's. So we'll go to the tenths place. We have an 8 here and an 8 here, so that does no good. Going to the hundredths place, we have a 5 here and a 0 here. 5 is larger than 0, so 9.85 is greater than 9.805. Number 4, we have 0.01 compared to 0.0101. Whole number parts are the same. The tenths place both have a 0. The hundredths places both have a 1, so now we have to move to the thousandths place. Well, the thousandths place on 0.01, remember if there's no numbers to the right, if the decimal stops, then there are these imaginary zeros, okay, after the 1. So we have a 0 here in the thousandths place. We have a 0 here, so these are the same. So now we need to go to the 10,000ths place. We have another 0 here in the 10,000ths place. Here we have a 1, and so that means that the second number, 0.0101, is larger than the first, so we'll use a less than sign to show that. Okay, what I want you to do is pause the video, and I want you to try comparing 5 through 9 on your own, okay, doing the same thing we did here in 2, 3, and 4. Once you think you have answers to all of those, click play to check. Okay, let's see how you did. Number 5, 5.07 is actually equal to 5.070. Remember, there's a invisible 0 to the right here of 7. And so if you compare all of your different places, you'll find that these are the exact same number. Number 6, we can just compare the tenths places here. 3 compared to 8. 8 is larger than 3, so 1.387 is less than 1.837. For number 7, we just have to look at the whole number parts. 62 is greater than 61. For 8, we have to go all the way to the thousandths place, and we see that we have a 0 here in the thousandths place compared to a 1 here. And then number 9, we go to just the tenths place, and 0 is less than 1, so we use a less than here. Okay, the last thing I want to talk about in this video is how to estimate decimals. So when we estimate decimal sums or differences, that would be addition or subtraction problems, we always round each decimal to the nearest whole number, and then we add or subtract. Okay, and remember, this is estimating. This is not getting the exact answer. This is trying to get a good guess as to what the answer might be using mental math. Okay, so that's what we're going to be practicing here. So here I'm asking you to estimate number 10, 86.9 plus 58.4. I'm not asking you to give me the exact answer. In fact, on your homework, if you give me the exact answer when the directions say to estimate, you'll actually get it wrong. Okay, the whole point of this is to practice using your mental math a little bit, or at least practice using your estimating skills. So 86.9, if we round that to the nearest whole, that will become 87. Again, look at the units digit. To the right, we have a 9, so we add 1 to the 6 to make this 87. And then 58.4, round that to the nearest whole, we see this stays at 58. So really, to estimate here, I can do 87 plus 58. And that gives me 145. So 145 is a good estimate of 86.9 plus 58.4. For number 11, we have 10.38. If I round this to the nearest whole, it just rounds to 10. And if I round 6.7 to the nearest whole number, look to the right of 6, we need to add 1 to 6, so this becomes 7. So this is like 10 minus 7, so an estimation of this would be 3. Sometimes you'll see me use this squiggly equal sign. We've used that before when we were talking about estimating square roots, and so that just means is approximately 145 and is approximately 3. So we sometimes use that symbol when we're estimating. Okay, finally, when we're estimating decimal products or quotients, that would be multiplication or division problems, we don't always round to the nearest whole. Sometimes we round to what are called compatible numbers. And compatible numbers are just numbers that are easy to use for that particular problem. When you're multiplying, you can either round decimals to the nearest whole number, or you can round them to numbers that are easy to multiply. With the exception of 0, it's not a really good idea to round to 0 because anytime you multiply by 0, you get 0. So don't use that one. When you're dividing, we round numbers so that they can divide without leaving a remainder. Okay, so it's not always to the nearest whole. Sometimes it's rounding down so that it becomes a number that's really easy to divide in your head. So number 12, if I estimate 32.66 times 7.69, well, 32.66 is close to 30. Okay, and that's actually rounding it down. Okay, it's not the nearest whole, but it's really easy to multiply numbers that end in 0 in my head, so that's why I'm rounding down to 30. And then 7.69, well, that's really close to 8. Okay, that will round up to 8 actually to the nearest whole. 30 times 8 we can do in our head. That's just 240. So a good estimation for this might be 240. Okay, number 13, 36.5. Well, 36.5 rounds up to 37, but 37 is actually a prime number, meaning it's not divisible by anything else, so I might actually just round this down to 36, which is composite. 8.241, even though it doesn't round up to 9, it's close to 9. Okay, so I could actually make this a 9, and we know what 36 divided by 9 is. 36 divided by 9 is 4. So we could say that for 13, the answer is approximately 4, and for number 12, the answer is approximately 240. Okay, as always, if you have any questions, guys, over this video, be sure to ask those in class the next time we see you, and until then, have a nice day. You're all wonderful people. Take care.